Hello and welcome to another evening of Rust. We will be doing a new game today. The game is called Smash the Code, and let's take a look at that right away just so we can get some interest for that. It's over in here. I can't believe I just had it open. So we were doing hypersonic last time, and we stopped doing hypersonic because it's compiled in debug mode and we wanted to optimize it, but it was kind of pointless because in debug mode you just can't optimize the thing. So we're going to move on to this one called Smash the Code, and it's a weird sort of Tetris sort of style game. Well, it's simpler. And let's just open up this full screen so we see it. I haven't read the rules yet. I've just looked at this thing, so I'm just going to guess as you destroy tiles like this, you shoot things at the enemy guy, and that's how you do damage to each other. And I presume one of you dies or one of you just gets more points. I don't know. We're going to find out in the rules, and we'll see what happens. Today we're probably just going to set the basic game, see what works, throw some stuff down. And it looks kind of like an optimization problem for each one where you put it in a row, where would you want to put it? Now, I'm trying to avoid optimization problems a little bit because we know we can't evaluate too much, but we might just be able to apply a heuristic to this one, so it should be okay. So let's get out of here. And I'm going to do 1 minute of advertising first on coding games so we can see right here. Let people know that we're going to start a new game right now somewhere on and join in. Nobody should wait to continue. So we have those. So let's get back to that in a second. Zoom out, go to stream. And if there's anybody over in Germany watching, that's us. Well, let's hope they get that. Let's hope they understand my broken German. And let's do that there. And hopefully we become watchers. Now, if you need to show, basically we're going to be programming a robot for this game, and we're using the Rust programming language. And we're using Rust because it was something new I wanted to learn at the time. And we're using coding game because it's more fun when the challenges have graphics. Although I must admit we spend a lot of time sort of in the code editor. There's not much I can do about that. You have to live with that. I'm trying a new setting on... Oh wait, let me just ignore that for a second. On Twitch, so there's something called a low latency feed now on Twitch, and the idea is that if you chat, I should just see the message faster, so we have better correlation to stream, because if you've watched the shows before, you will have noticed that when somebody types something, there's a good 2 minutes sometimes before I actually see what they've typed, and I've come up with an answer before somebody can help me. Alright, so I'm going to ignore the select file first, and get rid of this for a second. Can I highlight this? Good. And copy that. We're going to go over to Visual Code. That's what we use. We're going to use our skeleton project. I think we can close this folder. I'm going to open up the shell source/evening rust. Copy the skeleton to smash the code. Alright, then we're going to open up that folder. Open up folder, and we're going to call it Smash the Code. And this has most of our basic setup. We don't use the one file approach they have here. We split it off into things and we edit it offline so that we can do, basically proper coding. And so smash the entry, and this is where we're going to copy and paste the input that I got from their system there. Get rid of their thing here. Get rid of this stuff here and just put the game loop in here. And this is the basic parsing. This plays the game, and this does their exact basic setup. So we're just going to test the setup here and see if it actually works. We're going to do a clear and cargo build. This should be enough to get it running. And it downloads all the profiles first. And if you have any questions in the show, please just ask. Well, no, about Rust. I'm not an expert at Rust. I just only know what I've used in the show. But if it's a really tough question, I know experts in Rust, or you can jump over to Ferris's stream for Ferris stream stuff and bug him about questions too. He's pretty good at it. And otherwise we'd figure it out. We do some posts in the user call group, but not so many. And definitely about AI and algorithms, feel free to ask for that. Alright, so it's built. And now over in here, this is another tool, and these are all written on our site, the tools, Evening Rust. This tool is now called External Editor Integration, where the other one is called the Rust Source Builder, and we have links to them and the users that did them. Let's select our file, and let's go to source/evening rust/private. Smash the code, and single file is what we want to upload. We'll upload that to IDE. With any luck, this has worked correctly, and I have a running file. Now, I've hidden the things over here. This is the play one. Trust me on that. It executes it. I have them zoomed out just so we have the screen here bigger. Alright, so I'm doing nothing right now. And that's very okay, right? We're going to lose this one, I imagine. He just destroyed me somehow, and I guess that's okay. We don't know what the rules of the game are yet. So maybe we should read these rules now before we go any further on this. Defeat your opponent by grouping colored blocks. That much we got. A 6x12 grid, each turn, blah, blah, blah. Every pair is a random color. Colors labeled 1 to 5. You're 8 turns in advance. So we have 8 turns in advance. We saw that as well. Getting the same blocks. Good. The blocks are dropped into the grid from above and stop once they reach the bottom or another block in the same column. That seems reasonable. When 4 or more blocks the same color line up adjacent to each other, they disappear. Blocks connect so horizontally or vertically, but not diagonally. The whole group need not be a straight line. That's clear. I've played this type of game so often in life that, the basics kind of go with it. I guess if you've never played this type of game before, that would be pretty challenging to understand these rules. When all groups of the grid have cleared, the blocks above them fall until they reach the bottom or another block. If this causes new groups to form, those groups will disappear. This is called a chain. Aiming for large chains, increase your offensive power and lets you automatically attack your opponent. Attacking works as follows. As you create groups and perform chains, you will generate nuisance points. Alright, I guess we're going to be a nuisance in this show. And as soon as you have enough nuisance points, skull blocks will appear in the opponent's grid. Skull blocks act like colored blocks, but they will not disappear when they form a group. They are only removed from a grid if a colored block is cleared next to them. Got it. The skull blocks are dropped into the player's grid in a line, 6 at a time, 1 in each column. Skull blocks are labeled 0. We don't know what the other ones are labeled 0, but that's okay. Survive your opponent or have a higher score than him at the time. This is how we survive. We lose if we do something wrong, or we time out, or we fail to place blocks in the free cells of our grid. Simple enough. Groups and chains get scores, points, and nuisance points. The more points you use as a tie break if both players are still alive after 200 turns. Blah, 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 blah. That seems right. How do we actually play the game? So, first to center is column A and color B. The colors... So there is no general input for the game. It's only per turn. The colors of the blocks. In this league, color A is always equal to color B, okay? I don't really care about that, to be honest. Your current score. Characters representing one line of your grid, top to bottom. Alright, so we get the grid every single time, so we don't have to worry too much about that. The score of your opponent, and the opponent's grid. Well, that's interesting. I don't know any of that. Each line of the grid can contain the character's dot for an empty cell, 0 for a skull, and under 1 to 5 for a colored block. Output for one turn integer x for the column in which you want to drop the pair of blocks. You may append text to your instructions. It will be displayed to the viewer. Alright, we actually very rarely do that because we just don't care that much. Sorry. Oh, we have text here. Just a second. Flavor text is always fun. If I can stop coughing, that is. The terrifying Dr. Darkin is plotting to use the immense power of artificial intelligence to subdue and control the entire world with the help of super-intelligent killbots. Fortunately, Captain Wonderface has managed to intercept the villain just as he is about to trigger the start of his invasion. A mighty battle for the triumph of light begins as both superhumans face each other. Alright, so it's always a flavor text. I always, enjoy to read. We read it different every time, but I tend to forget it, but this one actually has some. I wonder if the new ones just don't have it, that's why I don't read it. Town-atropolis is a weird word. Okay, but good enough. On from here, we don't have much information about what chains and stuff give us in this one, just that they give more. So all we're going to do in this one is do the stupidest strategy we can and just keep placing them along the path. And I want to see, actually, is one move just the block placed one way? It is. So all we have to output each time is that one thing. So let's make it really simple to start with. Let's just take a counter. And let mut turn equals 0. And we're just going to do turn mod. What was the width of this thing again? 6 wide and 12 high. Grid width equals 6. And you have to type these things. Kind of annoying. Constant grid height. Height 32 equals 12. So all we're going to do is place them from left to right and see what that gives us. The Wood League of these things, the Wood League is quite often just to make sure you understand the rules and you can do basic moves. We don't actually have to produce a fully functioning sort of strategy. So right, we can see how we perform with just this now. Because I think it's the same strategy he does, so we're probably just going to end up tying, or no, we lose. Alright, so we're going to actually have to do a little bit of strategy here, I guess. But we're doing the exact same thing as him. Now, I'd be really disappointed if we actually do the same thing and he somehow wins, and he has won. Alright, so... Oh, crap, what are those things? I don't know how to disable those. I'm looking for an apartment, and I foolishly chose to allow it to notify me, and I have no idea where that's installed in Firefox now, so excuse those if they come up. Now, I'm curious to see as to... Okay, this is getting really pathetically slow, so let's go to at least 2 times speed. Now, what I'm unclear of here is why did he win? We had the exact same strategy. Oh, so he must have something where he puts it on to another existing one. Okay, so what we're going to build now is, I don't know what it'll take to get out of the Wood League. Probably not that much, but I'm at least going to track the board. So we're going to read in the board every time from top to bottom, and we have a matrix class for that. We're going to copy the matrix class in the previous place, and that was over in hypersonic source matrix. We're going to copy it over to source. We're going to reuse the matrix, and we're going to create a strategy file. We're going to start reading it in, or a state file. And we have a lib file here. We're going to open that up. No, source, lib. Entry, and we're going to have a pub mod matrix and a pub mod state. And so we're going to start creating the state, and the matrix is already there. This is a class I imported it. For these secondary classes like matrix, if you ever want one for your own project, just let me know. And I post this code for people if you want it, but the main strategy code I'm not supposed to be posting, so let's not do that. Whoops. Let's go on to state. And what did I say? Struct state. I call it the same in every project. It could almost be part of the implementation. State. Now we're going to do an exact mapping of the board. Very simple mapping to keep this simple. The colors, so each cell can have the number 0 to 1 through 5, and we're going to just make -1 mean an empty cell, and that should be clear enough. So a struct has a grid. This is going to be, no, this is a pub. I forget how much has to be marked here. Pub grid, and this is a matrix of, oh, sorry, that's the wrong language. Let's just call it an I-32. we're going to make this really simple. Import or use. Wow, use matrix. Something like that. Alright, so what we're going to do is we're going to say what do I want? I forgot what. I just want a default one, or probably let's say a new public function new. We don't need to really have a default for this. And this is going to return a self. Convention is if you're returning the type you're implementing, you return self instead. Then here you do a state, which is kind of weird. In a grid, and this is going to be a something like this. Matrix new, and this takes the size of the grid. And let's go back to the entry and take these ones back to where they're supposed to be. I'll put them over here, and then I'll just create here the grid width and the grid height. Now it's going to default fill those with 0, which we're going to have to fix. We want to fix them with -1. So let's do this instead. Let s equal state like this, and then we'll say s.grid.fill -1. And then we return s. So we have a new state. It's empty here. If we're going to see if we've done this correctly, well, it's ribs here, then we go over here and we're going to use state as well. Use state start. Now let's just try to compile and see if we have issues, which we always do. Matrix, what did I do wrong? Matrix, that's what I did wrong. Oh, iPoint. I forgot about iPoint. I have to copy that over as to source slash iPoint is an integral point of 2 dimensions. Alright. Alright, I think that's in the lib. We have to put it hub mod iPoint. Oopala, what do they do wrong here now? Uh-oh. That's weird. Oh, that's like a really weird error for this thing in hub mod iPoint 2. That's like a really weird error message. Not found in this scope. Grid width. Alright, that's the entry thing I changed. I screwed up. Let's just throw 6 for now until we fix the strategy. Alright, so I have some stuff to use. Now we have to read in the state. And we can just do this directly here, I think. So we're going to do let mut state equal state new. Good enough. And what do we have? Color the first block. We're going to ignore the blocks for now. We're just going to completely ignore them. And this is now the player's turn. So, and I have to convert these all to tabs because, you know, spaces suck. I'm using the indent character as a normal person would. So I think this is being parsed from top to bottom. That makes sense. The top is the bottom. So each row, then we just do this for I in 0. This should be 12. I'm going to leave it as 12, but this is going to be like state grid width, just so we're clear on this. I'm going to make these public constants too then. I don't know if you can do that. I assume you can. And, well, actually, I'm going to assume let's do this row.charge instead. Let's do that instead. Let mut x equal 0. And now what we'll do is we're going to say state.grid.set. And I forget what syntax it is because we don't call it very often. We have set with an I.2. And I really like setting with XY as well, so I don't always have to create the I point, so I'm going to add that as well. Set XY. And if you're new to Rust, no, you can't do function overload. It's kind of a limitation of the language due to how they do their traits or their type inferencing. There is a trait system though where some of the common scenarios you can essentially overload, but they compile slightly differently. But for member functions and normal functions you cannot overload. I personally don't like that, but I can't change it. And this is just our code for working with the matrix. The matrix has a single vector has a boxed vector, it's a boxed array of type T, and it manages that for us. Set x, y, we're going to do x, comma, I. Doesn't matter what that's going to be 2, and it has to be match C. And what do we say it has? A dot. Dot equals empty, and otherwise your colored block's good enough. And 1 to 5. Well, yeah, let's just do it with 1 first, minus 1. Now this is kind of stupid, but it's only 5 numbers. And oh well, let's not do the stupid way. Let's just do it correct. Let's just assume that the rest are type C, match C, and we're just going to say C as U8 minus 0 as U8. This is a really cheap conversion to ASCII. That's I32. And there we go. We have that as U8, U8, I32. And so we've parsed it into the grid now. So we now have a grid of lines that tell us the state. I'm just going to make sure this compiles first of all. Which you mean C, x, comma, y. This is y up here. Alright, I'm going to clear up the warnings first so they don't keep bugging us. More warnings, reasonable. I'm going to skip the warnings for now because it's only reporting 2 at a time and it's just getting annoying to me. Okay, but what we have now is we have the state written right in, and so we have our board. So the one way we can fix this first of all is because we're losing because we run the space first, is instead of just going left to right, let's make a very simple function where we start that says get lowest height grid or get next available space or something like that. And then we can optimize this later, but I don't think we'll have to. So let's do a public function get lowest column, and this takes itself. And it's going to return an I32. What column is this? And this is simply going to go through the columns for I in 0, dot, dot, and oh, well, there's a way to do this, but let's worry about the other loops things. There is a way to do this with high-level functions, and I keep getting it wrong in Rust, and this is not mutable, so it might be easy, but I do have a problem with Rust iterators and stuff, and the high-level mapping functions. With mutables, it gets really confusing, so I end up drawing back to normal loops. So we're going to have a second function first. Let mud height. And we're going to start with a height of self.height of 0. Let mud current equals 0. So it's a current 1. So we can start and go on I to grid width. And let h equal, and get rid of this, I'm going to fix this height, how it's spelled. Let h equal self.height of I. If h is greater than, no, sorry, less than height, then current equals I, height equals h. And this will end up filling them from the right to the left because the ones are the same height. No, it'll fill them left to the right because it has to be less than it. Good, so it'll fill up left to right, and it'll fill in holes as they come. So this should be fairly current. So we're just going to do current down here. Now we just need one more function. Doesn't have to be public. Item and self colon I32. It's not I32. And we'll do it this way for I in 0 dot dot grid. Now it's tough to say whether the height should scan from the top or the bottom. In this case, we're just not going to care. We're going to scan until... No, let's scan from the bottom because we can scan for the lowermost thing. And I don't remember how you do negative downward traversal, so I'll just manually do it. Self.grid.getXy, and X is column, and Y is grid height minus I minus 1. And this is greater than or equal to 0 because we set the skull at 0. And I'm just going to hard code that no. Then we return I. It works out, we return I because that's the height of the column. Then. Otherwise, what is the height of the column? If we get through that whole thing, we're going to say the height of the column is grid height, which you do without the returns, which had grid height. Alright, and now we're going to call get lowest column in the entry. And we're just always going to throw it in the lowest column. So state.get lowest column. Alright, let's see what happens. Let's see if that actually gets us anywhere. Or did I make a mistake and we fail? So I'm just and I obviously make a mistake, which isn't good. No more space. So I have some sort of mistake in my code because I keep reading that in state.grid.getXy, set XY. So usually in this state what I do is I write a debug function. The debug functions are the typical one function dump. I just call it dump, or let's call it edump to match the consistency of the naming in Rust. It doesn't have a return value. And Matrix also has a dump function, I think. I thought. Or not. Oh well, in any case, for I and 0 dot grid height. And this function can be super slow because we won't use it enough that much. Grid width. But as I said, this type of thing, when we analyzed it last week, like when I went through the Valgrind stuff on this turned out to be extremely slow because we're compiling in debug mode. Simple loops are extremely costly in Rust, and it really, really hurts us. But I don't intend to write garbage code just because of that. We're just going to have to suffer with it really being slow and not doing very well on some competitions. So, edump, so we're going to eprint. Just eprint, and we're going to do a match. Self.grid.getXy, just comma y. And the only special case we have is -1, in which case we want to put out a dot. And otherwise we just put out the number because that represents it. You might want to put a 0 and say, hey, this is a skull. Just make it clear. This is a star, it's a skull, something quite different. And then everything else we're just going to write as is. Pattern matching I really quite like from Rust. It has some nuances when you do with mutables, but the general idea behind it I really like. So we have an edump. So let's go to the entry and let's dump that out every turn. State.edump. And we can see that in the viewer then, if we get it right. Alright, I forgot that. Expected char, found I32. Now, did we now? Oh yeah, that's right. This is a how do I want to do this? I want to do C plus 0 as U8 as U as I no as God. as U8 or something like this. Oh, as char or something. Come on, give me a break. It's going to complain that it's not the same type now. Oh boy, oh boy, oh boy, oh boy. As U8, as ip32. Oh, come on. Let's just do this. C as U8 plus 0 as U8 as char. Alright, let's see what we have here. Did we actually dump it? Yeah, I think I called dump in the entry. Yes, I called dump. So let's see what happens. Why are we not dumping this? And we'll just let it show us here. It should show us in the output here what we actually see in our board. And I probably should put a print line there, but we see nothing in the board, which is kind of an issue. So we have to figure out why we see nothing in the board. Let's fix the dumping first of all, and do an ePrint line. State.grid is fine. State.grid is written with height and entry. What do we have for entry? And we should probably increment x here. But I don't think that's the issue. It said x, y match c. Well, I'm not clear. That shouldn't make that much of a difference. Let's print it out here. ePrint line. Row. What do we get out? Something very tired. I don't know why. Alright, so this is what it's printing. So these are rows we get. But we're apparently not parsing that correctly. Although, no, we are. Because we printed it again. I think we're doing it right now. Alright, so you can see the colors, you can see that we fill it in, so we are reading the state correctly, we're just not outputting the state correctly. So let's go back to state, and we're going to look at the get lowest column. Get lowest column is obviously doing something wrong, so we simply call get lowest column. Alright, so we do self height of, current equals 0, current equals I. So something is wrong with height of here. We start at the 0 in the grid height. And we start at the bottom. So we get the column. We say the grid height minus I minus 1 to do the offset is greater than or equal to 0. Return I. That means there's already one in there. That means we don't have any more height. So that makes perfect sense. We have no height in that one. And we dump it minus 1 goes to dot. So what are the heights that we're getting? Height of. Let's just do this. ePrint line. Debug what we're getting. So I equals whatever this is, I comma h. So something here is wrong. Let's figure out what. It says they're all at 12. Which is a bit weird. No. But we do print it, so there is stuff there. And the other columns are 12. No, the outcomes are not 12. They're supposed to be 0. Why are we getting 12? It says they're filled up. Kind of annoying. Column, comma, C. Let's do a whole bunch of it. Column, comma, I equals C. Alright, what do we have from this? I got nothing there. Let's run it. And a whole bunch of minus ones. This is correct. And what exactly am I outputting there? 3, good. There's some logic wrong there. C is greater than or equal to 0, return I. It's never going to be, so it should really be if C is less than 0, then you return I, because that gives us actual height. Yeah, I think I got that wrong. I think the barbershop just identified the same thing that I have. Well, I think that's what I'm trying to figure out. What does height refer to, actually? Height of the grid. And that makes sense. And I think that's what I just reversed here. This is your height of the grid, is that the default is basically if I found nothing less than 0, then it's completely filled up. Whereas otherwise we return I. So I think you're looking at the same thing. Alright, so now at least we fill up the empty columns. But it looks like we might actually need a strategy, which is kind of annoying. But we can look for one of the same color now instead. So if we have a color, we can look for a color. And we get a lot further than this one, but we're actually going to need a strategy still. Let's do 5 times speed. Let's watch and play this game, and of course, his strategy is fairly basic, so he might just be getting lucky, but I mean, we have to do something about this. And we survived a lot longer, so let's see what we do. We're going to have some sort of strategy. And how should we do that strategy? Do we just match the colors up to make sure? The barbershop, I was actually thinking about that as well. Just put all the same color in the same column, and but let's be a little bit more creative than that, no? Just match up 4 columns instead. I don't know. Well, let's try to think of something simpler. They must have had the Wood League used to be harder before, because usually in Wood League you didn't have to do much of anything to get by them. So we're going to actually have to do something to get by them now. So let's just... The barbershopper has a good idea on how to do that. And there's 6 columns. Well, let's actually just try that approach. We have the colors coming in, and now we're going to have to parse that as well. First of all, how is this parsed again? This is color A, color B. And so I think it's always the first one on the list. We get the first one there. So the state is going to require... Let's put this in the state then. We have... that's the barbershopper says using me as a beta test. And we'll see if this works, and if it does, he's going to do it. Obviously, if it doesn't, he's not going to do it. So let's encode this. We have, what was I going to say, though? Let's just call them blocks. I don't know what we're going to call these things. And this is a vector of I32, I32. No, how does this is how long? This is 8 long. Pub const blocks count is use size. It's 8. I always get the syntax wrong. Blocks count of. Damn it! What's the syntax again? I think I have these reversed. I don't know. Whatever. Blocks. Blocks can have a vec default or something. I don't know what this is. Vec default. Or no, it's going to be... Doesn't matter. You have to put something in here, though. A vector. Let's just do... I think that converts blocks count 0, 0. I just make sure this stuff works. I have a syntax here somewhere. Alright, so I got it backwards. I32, I32, blocks count. Expected, that's fine. I got these backwards as well, of course. Of course, of course, of course. How do you initialize an array? I've forgotten how to do that. We did it once before, but I really don't do it very often. Rust initialize array. The vector has like a toArray function, or there's some way to do it. Well, this is very nice. Why was I even trying to go there? What the hell site is it? What the hell is Chambers UK search? How the hell did that end up as my search engine? So we just take this off? Alright, so now we're going to read this in. In the entry, we're going to read that in here. Color A equals B, and then we're just going to use state.blocks. We're just going to totally assume it's the correct size. Blocks I.0 equals color A, state.blocks I.1 equals color B. Is it still working? We're still correct? We're still okay here. I'm going to get rid of this turn count. We just don't need that anymore. And I'm going to make one extra function we need just in case. And it's going to be a public function. I'll put it down lower because it's related to this one. Is open. Self column I32 is a boolean, and we're just going to simply do this has to tell us if we can actually place a block in there. Is open. Return self.height of column is less than grid height minus 2. The magic number, those are the size of the blocks. I can use a magic number because I'm using it in the type as well, so it's not something that can change on us. Is open. So what do we want? We want let column equal, and we're just the same colors, so we're just going to take state.blocks 0.0. If state.is open, wait, if not state is not open, column cell. And we're just going to stick it in the lowest one. Cell equals state.get lowest column. Now this is a pretty weak approach, but you know, we might get lucky. Just want to get it a wood leak. Have to start somewhere. Let's see what happens here. Let's play it again. Let's go up to the top so we can see it, and let's play it. We want to see this thing jump up to the top. If not, we just want to see what plays out in the game. Oh, we actually win! Alright, so the Barber Shopper, your idea works just fine against the Wood League boss. So we're going to go with that. Though he looks to get a massive combo here coming up, I don't care. Looks like somehow we still win, so it looks like it might be good enough. Let's just submit it and see what happens. Submit is this final button here that you can't see. We're going to submit that and see what happens. And this is very indicative of the fact that this is actually harder than the other Wood Leagues, that these guys, there's so many people in this list that got stuck on this league. Usually the Wood League is not, you're not meant to get stuck on, but this might be an older game. The newer games, it's really, there's like usually 3 Wood Leagues, and they're each a little progression, but we jumped up to 4 so fast that I don't think we're going to have a problem here. So, thumbs up to the Barber Shopper. Congratulations to you. Your strategy will get you past Wood League. Well, I'm assuming that. There's 2 more left, but the rate of momentum here, I don't think it'll be an issue. And there we go. So you can just look at the week. We were beating them all fairly easily. And you can watch the score here. We're at 22. It should be no problem. I'm going to make the wild assumption, based on the fact we're 22 and the next score is 20. We're already wildly better than 3. So, add this. Now we're going to add this one. Oh, I missed one from coding game before. Dot dot hypersonic. Source bin profile main. Let's commit this as Wood League 1. And so we're significantly better than the boss, as you can see that. I don't think we've lost any games, I guess. So anybody watching, if you want to pump play smash the code, that's the simplest strategy you can do. Just stick it in the column with the color, and if you can't stick it in that column, just stick it in the next one that's empty. That could even be optimized to just stick it in the last column first, starting from the other side. And that's an easy adjustment in our code. But we'll see what happens in Wood League 2, because Wood League 2 usually introduces new instructions as well. And that's what we want to see. Alright, so we're in the next league. Oh no! No, 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 no. That's not what I wanted. So our new instruction, these things can be rotated. As annoying as that may be. Alright, and we've been promoted. And I think we have to set up the external editor again. Or no. No, we should be fine. I don't know. Alright, so our stupid strategy actually gets us quite high in this league as well. But this league has a lot of people in it, 1,000. So again, this is hard enough. Must be one of the harder games for people. These leagues usually don't have that many people in it. Now, let's see where we're actually fit in this thing, where we get stuck. The first attempt here we can make is to just continue on the Barber Shopper as a strategy, and we're going to stick it in the same column, but if the bottom color is not the same as the top one, we're just going to rotate it. And let's just go with that. But we might actually get somewhere high in here as well. But anyways, let's just go with that anyways. Let's read the rules. What do we do? Blah, 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 all the same, blah, 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 blah. Oh, there's points here. I don't care about the points yet. That's for scoring later. What is the output change? So we have a pair of blocks such as 1,4 and a rotation. Alright, so we have these rotations, and I'm going to focus on just one. When you keep the 0 or 1 one, we're either going to, or, wait, that's a bit weird. Alright, for a pair of blocks 0 and 0, we take those. 0 is non-rotated, so it's no longer, it's going to the side, I guess. Now it must take that if you have no rotation, it just assumes what you had before. So the default is 1. So the default will be 1, I guess. And no, the default will be 3. Well, we're going to have to figure out what that mapping actually is. But we're just going to put 0 or 1 in any case. Let's just go with 0 or 1. Let mort-ora-y equals 0. It's a rotation. If state.blocks 0.0 does not equal state.blocks 0.1, then rot equals, actually we wanted the default to be 1. Default equals 1. If it's not the same color, and I'm not sure if the default should be 1 or 3, I guess it doesn't matter, but we want 0 in the other case. If the same color won't make a difference, so I just throw the rotation out there. Now we also have to check that this column here, and in this special case, and cell does not equal state grid width minus 1, because then we'd be sticking something outside the board. So in this case, we just don't rotate it. We just drop stuff in the 6. And in the state one, we're going to do one other thing. We're going to change get lowest to be less than or equal to height. And this preferences, because we use this to find the next free one, stuffing stuff on the right, so we keep the ones open for colors that we currently have. And this will give us some minor improvements. Well, at least I hope it will. Associate item not found, grid width. Grid width, I thought we called it before. What's the error message? Associate item grid width not found in the state. No, sorry, it's the wrong, I meant that state, not the state. Use state. That's just state new. Alright. Now, what's disturbing here is that we're getting surprisingly high in the rankings with that code that the barbershop came up with. Are we still ranking? Are we still going up? That would be bothersome. We are still going up, but we won't make it. We don't have enough battles left. So let's take the new code and compile it and see if it actually does anything better for us. The idea was that if we have the same colors, we keep dropping the column. If not the same column, we rotate it, and who knows what that'll do. And there's not many that are different colors here, which is kind of weird, which kind of makes the game no fun. And honestly, this is probably why we won, because it doesn't actually have any purpose to change rotating it. Right? Like, if you don't actually have two different colored ones, our change in strategy makes no difference. Oh, so he got like a massive combo, and so this boss is a little bit stronger in this one. We're having to probably do something. Now, what simple thing could we possibly do to make this better? I changed it ever so slightly. Let's resubmit it and see if the ever so slight change then makes a difference. Since they're always the same color, it's not going to make a big difference, and the rotation's never going to happen. But I started shifting pieces to the last column instead. Now this guy over here has an interesting strategy. Well, actually, it may not be a strategy. It looks like he just... Yeah, the barbershopper, I think when you have a whole bunch of them, and I think that's the key to getting to the massive combos, is just having... I don't know, just putting bricks all over the place. And the combo might be something you want to set up somehow. The combos work when you destroy bricks and then the other ones fall, and if they match up another 4, then you get a combo and it creates that. I'm sure if we found a way just to create one combo, we'd be okay. But what's a simple approach we can take? I'm trying to think if we create a combo, easiest way to create a combo might be... Yeah, barbershop, just make them fall down, so when the bricks get destroyed, the stuff, the empty space and stuff just slides down into it. Try to wonder, there's an easy way we can exploit this to actually get a simple strategy based on combos. You know, I do have an idea with that, based on that one guy, the way it actually worked. Why don't we just say the rotation is always 0 and just say hell with it? Because that'll actually create some overlap. Or does it make us place something in the wrong spot? Ooh, we did something wrong. If cell equals state grid width -1, rotation has to equal 1. Can't put it there then. So now we're just taking our chances here that we hope we get some sort of combo. I don't know if it'll work, but he seems to be building up bigger combos. And so that's clearly a heuristics-based thing. How is he building up the super combos? Let's try it again, find out. So he likes creating sets of 3, and there's definitely logic based in his. I'm trying to think of what the easiest way to do that logic would be. What's a simple way to create combos here? We see them in advance, but I don't really want to look at the advanced scoring quite yet. I don't know if he does, but this would make it a lot harder than the previous ones. So, what do we do now? We want to do... I want to watch one more. I don't know what I want to do. My brain's a bit fuzzy on this one. Is there a simple way to do this, to create these combos? We could just fill up the sides somehow and then... Yeah, the barbershop, that makes sense. I'm just trying to think of how you create the combo, because the moment you have 2, 4 of the same color together, it breaks the combo. Yeah, I'm testing out this new feature on Twitch that the lag is supposed to be lower, and I wonder if the lag is actually lower. So I can type a dot. If somebody just types a dot back, see how long it takes. The dot takes forever. My chat messages aren't going out. Chat. Alright, and so we can win at random. So I'm trying to think, what way can we make this work? That's actually a pretty good lag. The lag has improved, I guess. So this low lag option is better in Twitch. And I'd look at random, but let's just not do random. Let's just do a turn again. Let turn equal 0. I really just want to do something simple. I don't like doing strategies in Wood League, and the reason why is because they change the rules, and you don't want to focus something on the wrong rules. Turn mod 2. Do something stupid. We're just going to try something stupid. So I'm just going to keep alternating back and forth. That might break it up into little bits. Like, right, we get these little bits, but it's apparently not enough to do anything about it. Hello, Mayweed. Do I know you? Welcome to the show. We're just trying to find a simple strategy to beat this thing. And I mean simple because I want to get it a Wood League without trying to do actual anything intelligent. So this change in strategy definitely didn't help anything whatsoever. Oh, thank you very much, Mayweed. Thank you for the support. I appreciate that. And glad you're enjoying the show. I hope you're learning something. Or just having fun watching us fight things. Alright, so how can we... What are we doing wrong here? I mean... That's an option too, Barbershopper. And so Barbershopper and I, we just kind of think of like... We're trying to find a really brain-dead strategy to actually do this stuff rather than something complex. And the reason why is because we're stuck in the Wood League and we don't have all the instructions yet. And it's actually not a very smart idea to want to put too much effort in when you're in this point. Alright. Base spin. Oh, he's giving me a code. Thank you. What was the idea? Let's check this out. What does it look like in paste bin? And okay, I kind of see. And if you drop a second in the second column. No, I'm not quite getting what you mean here. So that's a 1122, 1133. Alternate based on height, and no, I'm not quite getting what you mean here, what you want me to do. Hopefully setting it. Then if you drop the 2 in the second column. Aha, okay. Okay, I think I'm slowly getting it. Bear with me for a second. Alright, but I'm trying to think of how do you... Right, okay, so what you're saying is that you're trying to alternate based on the height. So I don't think you want a mod 2. You want like some sort of Zoring thing. You want to flip the columns, that at a height you put it in a different column. And you get some sort of flipping. And so we're really just doing sort of a shift register. We're shifting them based on that. So if the height of this column, when we're placing it, if the height of the column is like, we'll say 2, we just place it in the next column. Or something like that. But this means I actually have to look at the colors, and that makes sense. All right, I think I have an idea of what you have in your head. Let me try and figure this one out. It's going back to the game. So if we're playing colors down here, the first blue is, assuming color 0 is blue, we put blue here. Then if blue comes again, we're going to shift it over 2 and throw it over here. Yeah, I'm going to use, and Okay, I'm thinking, yeah, I think I got it. So, alright, let me just think this slowly in the code here. Now, we're going to base it on the color first. We know they're the same right now, so we don't have to worry about it. And let's just, to hell with the colors here. Let's just skip the open. What we're going to do is we're going to set the height of this one. Height equals state dot height of, and I think I got to open that one up. Public function height of. Height of cell. If height mod we need to know divided by 2. If height divided by 2 mod 2, so we have an even 1 equals 0, so this is the base height. Then what we want to do is we want to shift the cell over by 3, and this will stagger it. Otherwise, we keep it the same way. And if that cell isn't full, then we choose a new one. And the staggering, I think, is going to set up what the barbershop wants. I don't know if it's quite the same. It's similar to... Because the mod... I have the divided by 2 here, because remember they come in sets of 2. Let's just see if this does anything, or I've done something totally weird. I'd love to see my name just jump up and... Yo! But that's bad. Index out of bounds. Well, that's not good. That's obviously going to cause us to lose. Alright, so this cell actually has to be cell plus 3. We have to do the wraparound here. Mod state grid width. Well, it doesn't win, but do we get combos? That's the key here. No, I'm not really seeing... I think we're not getting combos. Now, was that just unlucky, or did we... Why am I rotating sometimes, I guess is the question. Why do I do the rotation at all? Oh, wait, I forgot to change my rotation. I'm rotating by default, and that's bad. I don't want to rotate by default. I screwed that up. That's not what I want to do. But we won this time. I don't know why. And the rotation should default by not turn 2. We should be 0. No, 1. We're just going to keep them unrotated. And this should, if we have enough colors, this should set it up so the colors are halfly parse matched. Now that didn't work. You see, we stuck them directly on top of each other. Or I did. I mean, we didn't do anything. And the idea is clearly we did not, like, the whole purpose of this idea was that well, this makes it really hard to see. So we have a purple one coming. Now we have another purple one. The idea was that now, because this height already has some, it's supposed to shift it and put the purple in the third one, and it doesn't do that. It sticks it in the same place. And the same with the blue. It should shift it over and put it in the 1 now, which it doesn't. And the same with the green. Alright, so clearly I didn't actually do what I wanted to do here. So the cell we wanted in, we take the height of it. We divide the height by 2 because we're blocking these things in heads of 2. We're assuming they're too high always, which may not be good or not. And we're saying if it's even, then we shift it over. But this appears to never trigger. Alright, it should be, if it's odd, it shifts over. That's why it'll never trigger. I think, maybe, who knows. Yeah, now you can see the staggering. Let's see if it actually helps any, though. Obviously not, because we're still failing here. Alright, but what we need to do now... Oh man, we need to actually get in there and trigger these things, so... Man, I don't know, what can I do? Let's see if we're better than anybody else. Let's see if this actually does us any good in the overall strategy thing and see what happens there. That'll give us a good idea of whether we have anything useful or we just have random nonsense. What I'm trying to avoid right now is the searching. I'm trying to avoid looking in the grid and putting all the things and seeing which does the best ones. Because I've been trying to use a heuristic that makes it simple, which may not be the wisest idea. Like, these guys are using already, as far as I'm concerned, Wood League style pretty more complex than I expect for Wood League. So I gotta figure out, and this is, again, this might be in the older games. They changed the logic behind Wood League since then. The Wood League now is really just to get to the rules, but it looks like we might actually have to implement an actual strategy, which was not my intent. I was hoping I wouldn't have to do that. Alright, what can I do instead then? What can I do? Let's play one more. And again, right now I'm trying to just look for cheap solutions, cheap shit. And we won that one. And that's because we get lucky, probably. Alright, so now the issue is that I'm going to do something else. I'm going to do some random check here as well. Let mort-ora-y equals 1. And if this is the case, we're going to say rot equals 0. Well, the barbershopper, I just don't know because we're not guaranteed the colors, so I don't know how I'm going to hard code that because we may never actually get the color combination we need to trigger that combo. A hard coded combo requires, yeah, I just don't know how to do the colors unless we have. I just don't know. I might think about it though. That would be probably next. Rather than just trying random shit. And like he's building up threes. And this is what I find interesting. Let's see how he builds up those threes. Let's look very closely at him. He builds that up, and he stacks the colors. So he keeps stacking the colors. Fine. And as soon as he gets the first duplicate color, he sticks it in the other side. So this probably one is too high up. And then he stacks them. Oh, and then... Alright, so I think the logic there is if he ever sees a chance to produce a 3, he produces a 3. And then you got the green ones. But this really looks like he looked to the colors in advance. I don't see this as like, I think he looked at the colors in advance. So let's keep moving on though. Then he keeps more. Then he saw 3, so he created the 3. Then he just keeps stacking them up. What would he get? There is a blue one there. Alright, then you got to... I mean, the level of combos that he's getting... I have a feeling it's actually that this AI is actually looking at these colors and seeing, well, what can he do? And what level of depth would we have to do to make an actual search worthwhile? Can we actually jump into the proper searching? So we have 8 steps here. For each one of them, we actually have, well, this is unfortunate because of the rotation. Oh, we screw rotation on this one. We have 2 states. But in full set, we have 6 times 4, 24 states and 8 combinations. That's the total number of moves we'd actually have to evaluate. Let's check that one out. Could we actually do that? Should we just jump into the actual calculation mode? So what I mean by 8 steps is you have 6 columns times 4 rotations. Several of these will be pruned off, but I don't care. And this is times, and this is for every one, times 8, no, to the 8th, isn't it? This is to the 8th then. This is only, to evaluate the complete board requires 393,000 evaluations. And the reason I don't want to do this right now is I'm immediately going to get to the case where we had in the last game where we can't do this in Rust because we're compiling in debug mode, but this would be the simplest approach. Just pack the board and then evaluate whatever comes. And that's way more work than what I do. I want to get out of the wood league first because I don't know what's coming as the next instruction. So I really hate the idea of setting this up beforehand. But it'd be the cleanest approach is that if I had this offline, and this doesn't seem like a huge number, but it's big enough in debug mode because it's going to be 20 times the speed. So 20, this puts us in 3 million. This puts us in millisecond range, even if we're perfect. Yeah, we're not going to be able to evaluate that many, but that would be the ideal approach, is to evaluate all of them and just pick the one that's fastest. So instead, we're going to have to pick some clever way to skip that, because I really don't want to do that this round, because, again, I'm going to just repeat that one more time. Until I'm out of the wood league, building up actual strategies is usually pointless, because you just don't know. You might have to throw away all the code. So what I'd much prefer to have, and something else. I'm going to check some. Is the code actually changing here? It is. Just make sure, because it's usually highlighted differently when it's external. So how do we hard code 1 then? What can we do? Anybody have clever ideas? I'm at a loss today. I must be tired. Oh, by the way, from use from the old show, one of the old shows, I don't remember which thing we were allowed to apply for quant position, actually, it turns out to be. There was if you finished the one challenge, you could apply and potentially work with senior bankers, as we made fun of. I'll be honest, we made fun of it. And I actually managed the application. Finally, they gave a call back, and I have actually started the interview process with them. So I'll let you guys know how that goes, see if it's anything interesting. It looks like quant positions, and honestly, I'm not a quant, but I might be able to make it through the interviews. We'll see what happens. All right, so back to this game. I'm sort of stuck now. How do I do a simple move here? Like, I mean, there's a lot of simple strategies that aren't simple, like logically. Like, I might take 2 colors and put them here and here, and then wait for the third one and just pile it in there and let them fall down. But if you don't stagger them, and this boss is already staggering his stuff. He has staggered combos, and that's really, really wacky. How do we do that? How? It's really like anytime he sees a combination for a 3, he takes it. Maybe we should just do that. Maybe we should just look for combinations of 3. That is, anytime you have 2 stacked on the top, which we usually do, we just rotate it and rotate it and rotate it. But we already do rotations, and it's not helping us, right? Like, we do rotate some stuff, but I'm kind of running dry in what I do here. I mean, I don't want... Oh, come on, what can I do? I said I'm trying to avoid the actual simulation and figuring out, but maybe we should just do that. Maybe we should figure out the simulation. Because if you look at this one here, did we ever have a point where we could do something really good? Based on a one-move evaluation? I don't think we did we? Right here. Right, this is the one case I would prove to. We got to this point here, and we have a blue one coming. Now, placing blue down here would destroy that. It's not a combination, but at least it's something. And we might just want to just say if all of them are filled up, let's look just for a place. I would say if we can, maybe we should do for that. If any point we can destroy something that's underneath something else, then we should take it. And that would set up at least the potential for a combination. We don't get the combinations, but at least it sets up a potential. And we just destroyed something stupid there. And we have the exact same thing again here. We have a purple one, and we put the purple ones to here. And that will be the exact same thing when we detect. We have the option here of actually destroying one that's underneath. That doesn't necessarily set up a combo, but it sets up a future combo. Because if we did that, and then there's more combos, and green again, right here, we'd have another combo if we just drop this one here. So I think this logic makes sense. Why don't we do the normal one? If we ever detect a place, and we'll build the detection in now, if we detect something, and sorry, if I detect something that will cause things to drop on top of other ones, then the hero will take that one. Then I'll take that one. So here's the green one. If I detect that there's a green spot and it's underneath something else, it's going to take that one and take that. But we have to do the detection first, and this would be another case. Here, yellow. All right, so there's a lot of cases where this would come up that it looks like that maybe that would make sense, but we have to build the detection in. Okay. That means an actual simulation at this point. Given a piece, figure out what happens to the board. And this is why the game's labeled as flood fill, because given any matching pieces, you want to find all of the areas where they actually match. You want to find the full size of a matching piece, which is a flood fill. It's a very tiny flood fill, but nonetheless, it's an actual flood fill. And because it's a flood fill, you go back to this number here. This is not going to be possible with Rust in debug mode. It's simply not going to be possible. There's no absolute way we can do a flood fill on this thing 393,000 times and expect to actually get it to perform within the 100 milliseconds. So we're going to actually have to be clever here. I'm going to have to find a way, but I need at least one flood fill. The flood fill to just detect, drop a column. Let's do that. So let's take that. So we're going to predict it. We have to do the prediction then, but I'm going to break this off into a strategy then. Let's see how I can do that strategy, and that's another file then, unfortunately. And screw it. Let's not do a strategy. Let's just do it all inline and entry for now. We don't need to test this stuff yet. Or, yeah, no, strategy makes sense. No, just state. Let's just hard code it in state, strategy. Let's create another file. Come on, I don't like that. This becomes really complex far faster than I want it. Strat. Impulse strat. So it's coming off to a slower start than I wanted as well. And obviously this is using state. Stars. Or just use state, that's fine. Strategy, we don't have to care what's in it. And the move is comprised of two numbers, so we're going to say a public function, and this is a public struct, and this is the public function. get best move. And I'm actually not even going to make a strategy thing, or we actually did it before. Strategy. Yeah, let's just do strategy. Get best move and self, state, and state. And this returns a combination of I32, I32. And the first bit we do is move over all of this stuff over here. I take all of this and it just goes in there. So we're going to create a state first of all, or a strategy. Put that in our lib file. Lib file, I don't like the way we have to do this in Rust, but that's okay. Strat. I'm going to stick it here. Let mut-strat equals strat new. Strat new, and it's going to need a new function as well. We already know we're reading the state correctly, so we don't have to put that one there. Let turn equal strat dot. How can I flip between tabs? Oh, get best move, and state. Turn dot 0, turn dot 1. And this becomes our driver, and it knows nothing about strategy. Get rid of the other stuff. Get rid of the turn counter. I don't care about it anymore. Move it somewhere else if we really want it. Actually, let's stick it back. No, we don't use the turn anymore, do we? Just get rid of it. Get rid of this, and then put all this down over there. So this is what ends up happening with all of the entry code and all of their projects. All the entry code does is read the input into the state, and then you call the strategy get best move and outputs. This is the interface with the system, the actual, and then the rest of it goes in here. And we have state blocks wrote 1. There we have it. And this is the old state. So this would be a matter of cell comma rotation, and this would be the existing strategy. And this should work with the existing strategy. So I think we need a new function first of all. Public function new self, and let's do it. Let's do strat. I have a hard time writing strat. Not a type. Alright, state is probably a state then. Probably a state even. Okay. And so that's the exact same strategy. So we're not changing anything yet. I've just put it into a separate file. And that gives me something a little bit more interesting. But now I'm going to look for identifying for each of these moves what actually happens, what gets destroyed. And I don't have to look for chains. I'm just going to look for a simple thing first of all. I'm going to look for big functions of the board. So function and well, that's the first thing I should do, is an apply function. This is always the typical thing we want to apply. Apply, and it takes the mutable state, and mut state. That's the first thing, and that's given a turn, and a turn is a I32, I32. And this is going to modify that state. And so given a state, let's apply it. And I'm not going to update the score, or how do I update the score? I'm just going to apply it, and it's going to be apply turn, so I'm not going to actually execute the state. I'm just going to apply the turn. And this already starts getting hard to code, and we might have to get back to this tomorrow, but let's start doing it. I have an hour or two left, but I'm getting tired. My eyes keep closing. And so by what I mean by apply turn is that in this position, whatever turn I come up with, I'm going to put this blue one somewhere. I have to be able to recreate the state of the board right afterwards. So when I put the blue one down, I say put it there, and I have to be able to create the state that says, alright, the blue one goes there then. And the way we can do this is I can break this down into 2 bits, because we have 2 blocks that essentially fall on their own, based on the rotation. You have 2 blocks, so you have the 1, 4, and this is the order and what they're given at the top. And given the rotation, it changes the order of them, and it changes what cells they're in. So what I can do let's just, so this takes, we're going to split this up. We're going to split this up, let just Q equal match turn.0. And I'm going to simplify out let block equal state.blocks 0. I'm going to take that block out of there so we know what it is. And we're not going to match turn 0. I want to match turn 1. This is the rotation case. Oh, I hate when tab does that. So to explain what happens in the 0 case, and we'll do the rest later. A 0 means that the first block is in the first cell. And that first block is block.0. And what cell is that in? And that goes into turn.0. It's really in that first block. And that's saying if I pass it in, this based on this cell, put it here, and it goes into that first cell based on that rotation. And then for the second block becomes block.1. And the reason I'm doing it this way is because this is an ordering. It's very specifically saying this one, then that one fall. Because in some cases it rotates. And particularly in this case, it's a different order, so I have to change the block. But here it says turn.0 plus 1. Because that's a cell plus 1. So now I have two independent places where I'm going to stick these blocks based on the rotation. And Q then is a tuple of those two. And then I have to do something similar for 1, where 1 rotates and it puts a second one on top. So the first block is actually block.1, but it's in the same, it puts it on top, meaning the first one falls first. So block.0 falls first, and then it's at turn.0. And then block.1 that falls, and it's still at the same location, turn.0. Now we do 2. And 2 puts the right block first. And I just can pretend that one happens first. So block.1 at turn.0 minus 1. Block.0 at turn.0. Alright, so that sets up those two blocks. And the final block, which I'm just going to put like this so it doesn't bitch at us, is it puts the first block on top, meaning the second block falls first. Block.1 at turn.0. Block.0 at turn.0. All clear so far. This is working in my head. This is all clear so far. So Q now has sets of, we've basically broken up the blocks into two independent chunks of blocks. And I can show you this now by saying, let's just simplify a turn block to a state and mutable state. And we're going to say what block it is. This is an I32, and to what column is an I32. This is what this function is doing, and this is going to be called twice now. So we're going to do apply turn block with the state on Q.0, because that's the first block that falls, and apply turn block state on Q.1. That's the second block that falls. So this creates the two block combination. It falls and it falls. Now I have to do that, and I think this is just a matter of, well, I'm going to do something a bit crazy here, return a Boolean. This could be wrong. If column is less than 0 or column is greater than or equal to state grid width, then we return false to say that this move is not valid. We've corrupted the state in any case. Because there's two moves, I don't care. We may have corrupted the states, so I just don't care about that. And so given this column, we want to find the height of that column. So let h equal state dot height of column. And then knowing the height, we can set the new one in. But we have another failure condition. If height is greater than state, greater than or equal to state grid height, if we're already filled up, then we return false as well. Otherwise, state.grid.set xy column, comma state grid height minus h minus 1 becomes the block, and that sets up the block. I think. We should really set up the test cases immediately, but let's just try to compile this anyways. Apply turn block. Forgot a semicolon there. It's fine. I'm going to use state as star as well, just so I can get everything in there. And what state? Oh, wonderful. Found a tuple with 3 types, expected one with 1. So one of these is wrong. Am I missing a comma somewhere? Which one doesn't have the same value? Alright, it's kind of annoying me. I'm not missing a comma. One of these has the wrong type. Expected type. None of them should have had this type. None of them. Found this type. This is the correct type. So which one's returning the wrong type? Alright, now that one. Well, that is happy if you only return one type. What's the difference between these two types? It'd be really nice if it told us, well, it says that arm, but why? This looks identical to that one. What if I put a +1 down here? Alright, does anybody see the error here? Anybody see the problem here? What have I done wrong? Aha! There's a comma here instead of a dot. Alright, that would probably do it. Other problems are other problems. Q.0.0 and Q.0.1. Q.1.1. There we go. What's the problem with this? You can't do that? Alright, I complained about using .0 and stuff before in Rust, and if you really have to do this to avoid that error, that would be a good statement in favor of not having .1, .0, but having some proper subscripting. Because this looks like a parsing error. They had an ambiguity in parsing, and so you're forced to resolve it. And I really don't like that in the language when you're forced to manually resolve parsing ambiguities. And when I do my own language leaf, I'm really trying to look forward to avoiding these types of ambiguities. If you look for them, make sure the syntax doesn't have them, so you don't have weird stuff like this. And the reason why I say this is weird is because you had named things, a.x.y would work just fine, And in my opinion, a.0.1 should have the exact same syntax then. The fact you have to do this on this form indicates there's actual ambiguity, and it's a limitation of the language that you can't chain them correctly. We don't know if this works. I'm not going to do test cases right now. Right, because we have to write one more function, and well, we can test it right now. Let's do right here. Turn equals this. Just going to return the turn. Let dup equals state.clone. We should probably make a clone function. Then we're going to apply the turn. And let state turn, and then we're going to do dup.dump. And I should probably do an ePrint line here first. Applied. So when we output, we can at least see what move we're applied, and that'll let us just test it relatively quickly if we're testing it that it's working. Entry doesn't do a dump, so let's do it here. State.edump. We'll dump out both states, and we'll dump the turn, and that should be enough to... Yeah. Semicolon. Oh, I don't know why that suddenly changed the type of that. And mode state apply turn. This has to be dup. Cannot borrow is mutable. Why not? Why can't I borrow this as mutable? Because it's already... What? Just end up... I fight with this a lot. The pointers in Rust are confusing. And the reason they're confusing in Rust is because sometimes some things are implicit and sometimes they're not. And you just have to magically know which cases where there's like an implicit thing. And all I want here is to pass the stupid thing in. I have a feeling end clone should have worked, because if we went to the entry points and state and so I don't know why the hell that's not working. Cannot borrow is mutable. Cannot borrow immutable. Borrow this content as mutable. This is the general Rust message saying like, hey, you did something wrong, but I can't actually tell you what it is. Alright, maybe there's something with states. Maybe we haven't implemented clone, so let's do that. Derive clone. Alright, so that was a case where the error message you got out is really, really useless. By not been deriving clone, it got totally confused in the types, and it's a limitation, I think, of Rust's inferred type system, and I'm not actually a big fan of their inferred type system. It works in some spots, but it has significant limitations. It produces really funny error messages, and it doesn't allow for overloaded functions, so I'm not actually a fan of their inferred type system, the way they do it, the balancing. It's cool in some examples, but it's not something I ever really care about, those examples. Alright, so we implemented that, we compile it. Now we're going to see what happens if we play this game and what comes out of this. Let's go back and play the game, and I just want to see if the apply function does something correct or not. We can simply pause it here. And we go back up. Let's go to the very start. It's easy to understand. So we have a red one, and it's empty, and then when we apply it, we have 4,4 over here. Does that line up with what we get up there, red? It does. Then we have 4,4, and applied, we're putting 2,2. Okay, now I'm going to check the first one here. We're turning the red one and getting a 4,2 and a 4,4. Let's see if that's correct. Alright, so it looks like our apply function, it looks like my apply function actually does the application correctly. It drops the blocks to the right location, which then marks it there. That should be fine. Okay. Now the next step is we want to identify, well, how to remove, or actually, in our strategy, we don't actually have to remove the blocks that are the same color. All I want to do is count them. And I'm only looking for ones that are wow, how do I do this? What's the easiest way to do this? This is going to be extremely costly in debug mode because I know the functions I want to do, and it's lots and lots and lots of flood filling, but they involve a lot of temporaries and a lot of fills and a lot of stuff, and that's going to just be awful. In practice, knowing from the last one, where I said we had 300,000 combinations to evaluate, I'm willing to bet you get up to like maybe 1,000 at best, and that makes it totally pointless. And so the strat combination now, we want to have a function that says is underblock destroyed. It seems reasonable. Is underblock destroyed in this state? And this is just a Boolean. This is a very simple score function because I'm trying to check that just that one condition where we can destroy a block underneath one that's already there. How is that tested then? Or rather than answering that question, maybe I should just destroy all those blocks. Let's just destroy the underblocks. Destroy groups. This is a mutable state now. And this goes through every single state on the board. Lots of fun for y and 0 ... State grid height. For x and 0 ... state grid width. Destroy group at. You can give it the state again. Take the state if you want it. X, y. I'm trying to think if there's a better way to... I've done a game before where you build little castles and you attack them and it flood fills everything on the screen and it detects the size of those regions. And I'm trying to think, how did I do that before? Because you could do a single flood fill on the entire board and figure out the counts of them. But how did that work? No, because I was trying to flood fill, I was trying to find unique areas, and I did find the size, but I'm not sure how I found the size. So this is an annoying flood filling one, and I'm going to get you a bit forward in the flood filling to show you what I mean. So for the flood filling, what I have to do is I'm going to go through every one of these, and I want to check, it's like, well, how many are here in this group? What is this group, first of all? Identify a group, and this is a group of 1. I have to be able to identify this is a group of 1, and this is a group of 3. If there's ever a group of 4, then we identify it for removal because it meets the criteria. Greater groups are even better. And I need a way to identify these groups. And what a flood fill would do, but a flood fill isn't good because I already have the groups colored. What I want to do is I want to count it. I want to go to this one and say, so how big is this group? I want to both identify the group and how big it is. And you can actually identify it in that you create a list of the items in the group. And this is an okay way to do it. And I know it's going to be super unbelievably, horribly, terribly slow, but how can we do it? And I'm wondering if there is a walking way we can do it. Instead of doing a flood fill, can I walk through these things knowing that we never walk in a certain direction? Because if you have a long list, you can walk, 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 walk. So if this one was, pretend this one was red. Pretend somehow we got red here. You have to identify this whole group. And if you're starting here, we'd be starting here. You have to go each direction. We go right, it ends. Then you go down, down, right, down, down. That's easy, but if you have blocks, in different orders, you have to be able to walk back and forth. We could keep a stack of visited nodes. That's an option, and scan it, and that's super slow though. Or how can I identify these nodes? I'm going to scan them and figure out which nodes to destroy. Oh, what's an easy way? I know it's a filling algorithm, but I don't want to. So I could fill, I could just keep the list of nodes visited. I could keep a shadow grid. That's the way I'd probably do, is I keep a shadow grid of visited nodes. Oh, let's just do it that way. It's slow, but it's the way I'd actually do it. And the reason why I say it's not so good is we know from debug mode, I'm totally tainted right now with the debug mode, because the debug mode here means a simple fill in a matrix is unbelievably slow, even though it's supposed to be super fast. Like an 8x12 matrix should be super, super, super fast. And we can actually make, when we optimize this in the end, if we're in release mode, is we'd create a bit mask then. So the bit mask for 8x12 isn't that large. And the bit mask then creates a very simple way, a visited node, and that'd be a lot better. So why does Rust have a bit mask, maybe a bit set? No, that's not going to help a bit set in Rust. And my connection is not secure. Wonderful. I don't know why it's... What the hell? Chambers. How the hell did I get Chambers as my search? That's pissing me off. Is bet set in the standard collection? No, it's unstable. That's not what I want. In any case, we're going to pretend we have it. Did we use bit set before? I thought we used bit set before. Let's figure that out. Find ... name started rs grep. And that's what I want. I want grep bit set find. Apparently we did not use it before. Did we use a set of any kind? Hash set. Okay, I used a hash set. Hash set has the same thing. Let's go with that for now. But what I want is a bit set, because bit sets are extremely fast. Bit sets, if implemented correctly, can get you near free if specialized, because it's super fast how to do them. And 8 times 12 is 8092. You can actually do a bit set in a single 128-bit integer, which the platform probably has, which makes a bit set. And what I'm doing the bit set for is when I do my flood fill is I'm going to scan to see have I already checked this position. And since a complete thing sits inside one 128-bit integer, that check is virtually free at the level. It's like one clock cycle in release mode on an optimized hash or bit set. But for now, let's just use an unoptimized bits hash set. Hash set, destroy group at. And what do they want to do? I want to count the group at first. Alright, this is taking a lot of work. State is an and mut state. X and I32, Y is an I32. So return anything. I might return something later. And the first thing it has to do is count the group at it. Well, let's do that. Yeah, let's just generate a group. Let's do it the really inefficient way first. Let's just do this. Let group equal get group at state, comma x, comma I. Get group at. And this one, rushly knowing it has to be a mutable state because it already has a mutable state. You can't borrow it immutably at this point or something like that. I don't like the limitations, but I don't care. I32. Let's pretend this is going to work, first of all. Let's say this is a state. This shouldn't have to take a mutable state. And this returns a vector of... It's going to return a vector of I.2. This is highly inefficient. Now let's just return a vector of I32. These are linear addresses within the matrix. The matrix has a linear addressing system as well as a point-based addressing system. This will return linear addresses. And we have conversion functions in the matrix for that. And we have a visited set equals hash set I32, also linear addresses new. As we visit a linear address, we're going to add it in there. And there's going to be an open set. This is going to be a vector I32 new. As you can see, flood filling is extremely expensive in terms of allocation. In an optimized version, this all goes away because we know the fixed size of this. We can just stick this on the stack. We can reuse the same things. And this, in a release mode, this actually overhead gets really, really tiny for the actual collections here. In debug mode, this becomes unbelievably unbearable. But that's okay. And so what do we visit it? We have to convert the linear xy equals. And then what do I have? I have linear get. Locus linear. I need a function that converts to linear. Public function linear xy and self xi32 yi32. And this converts an xy address into a linear one, which simply returns, as these other ones used down here, y times self.width plus x, and that's the linear address of it. Whoops. And there's also an isValid, and we should probably do an isValid len, pubvalid isValid lin linear address. I've been calling them linear. No, linear. IsValid linear. Well, what do they call the get? Linear set, linear sets? Alright, so linear is valid. Linear is valid. And self, and it takes in a location, and it's an I32. Linear checks are cheaper than the isValid checks because you return simply lock is less than 0 or lock is greater than self.width times self.height. Actually greater than or equal to, because then it's invalid. So you need to return it. Just return the value, and this is also the same thing. So you need to return it. So we have linear addresses, and now I wanted this function linear xy. Linear xy equals state.grid.linear xy of x comma y. So we convert it to a linear address, and then we see the thing visited.set. Now, how do I add stuff to a hash set? Insert. Visited.insert linear xy. So we mark this one as being used, and open.insert. Now we add it to find it. So we set up the loop, and then basically while open.size or size? While there's anything open, we reloop it. Then we have one more vector, let found equals vector of I32. More vectors. And found, we also found the first one as well. Or did we? How do I want to do this? The visited ones, and do we need the open ones? Probably as we find them, let's do it. Now there's a pop operation in here. While let lock equals open.pop, I think like this. I hope that's remembered. That is let lock. Then we can say found.insert, found.push, and open.push here, open.push. push lock. So we found one, and in the very end we're going to return the found set. I know this stuff is extremely hard to visualize from code, and I've really been meaning to do this in the Leaf stream, show how this stuff works, and take these algorithms one by one and really show how they work, but I have to get some more graphics done. That's the Wormies game, and I can show you the Wormies games right now as sort of a interlude to that. And the Wormies game is, I was setting up to show how you could visualize these grids, and it's a game. It comes from the Tron one, and sourceless leaf dash Wormies made distribution leaf. That's the current program I'm using, and then just wormies.leaf, that project. All right. So this is what I'm working on in the other stream. It's a simple Tron-like game where you eat berries and stuff like this, and your snake gets longer. The reason why I bring this up is because this will help us visualize the types of flood filling and stuff that we're doing. And I just want to get to the point where I can actually do that, since you can clearly see this is grid-based, and it has the same type of logic in it. It's going through a grid, and I actually want to get this to the point where I can use that for these shows, maybe a simple language that we can show how these algorithms work, or I just code them one by one in Leaf and show how the flood filling works, because if you had it visually, it's a lot easier to understand what this code I'm doing here is right now. But let's just go to code. Can you try to visualize in your head? Anybody who can visualize in the head, please put your hand up. That's very impressive. You can visualize what I'm doing here. I've done flood filling like probably a few hundred times, to be honest. It comes up a ton in a lot of different domains. So alright, so we open that up, and so now we have a location here. So we have a couple things here. If state.grid.linear is valid, lock. If it's not valid, then we just go on our way. Just forget about it. Okay. That simplifies the next step here. Oh man, how do we do closures again in Rust? Well, just create a closure here. Let's do actually simplify it. Add open equals some lock. If visited dot hash set, how do you say contains? Contains. If visited does not contains, and state.grid.linear is valid. Lock. If it's location, we just put them by one, then we add it. Visited dot insert location. So we're going to use a closure to add that together. I've never actually used a closure this way. I'm assuming it's going to work. No reason why it shouldn't. We're going to assume the initial address is valid, so we push it in the visited list. We add, we push it in the open list and the visited list. Open dot push location add open. So if it's not been visited, then we mark it as visited. That should be good enough, and then we push it. So we only push new locations. And then as we go through the group, we push them, and then we have to add open for a bunch of different locations. Add open location +1, add open location -1, because these are linear addresses. Add open location plus state.grid.width, because this is how linear locations work, and add open location.state.grid.height. Now I just want to make sure this compiles. We don't call it yet, but that's okay. And we're going to have to import the hash set and crap like that. Expected bool because of return type, destroy groups. Let's just return false. We didn't destroy anything, that's fine. Pop, no, okay, pop. Expected I32, found and I32. Oh, come on. That's the thing about references. It's just pissing me off. Why the hell does this have a reference? No, seriously, why is this a reference? This is an I32. It's not a reference type. Consider boring. And hash set requires a reference. I just shake my head at Rust sometimes. Come on, guys. This is it's not an easy language to use. I'm comfortable enough with the language to say this is not an easy language to use. Rust is, personally, I find it harder to use than C. It has a bit, obviously, higher safety, but it's just not an easy language to use. And wait, no, this is supposed to be... How do we do the popping loop before? Rust while pop. Come on. Whoever Chambers UK searches, I'm assuming is something on your page that screwed up my search, and I'm unimpressed with it. I've done this before. I don't remember how. Is you can pop things off a loop and do the loop. There's something like this. While locus open pop. So as you continually pop stuff off of it, is it like a while if let or something? No, apparently not. Or it is. No, it's not that. Right, because you can have... Oh, wait. Well, let's some... Like, I think that's maybe it. There it is. And... Cannot borrow mutably. Mut visited. And cannot borrow. Now I have no idea why calling a function requires it to be mutable. That doesn't make any sense. I'm not trying to change add open, I'm trying to call it. That's really unclear. I mean, really, this is a big, what the, W2F for you, there you go. I don't understand why mut is required. To call a closure. Like, closures are always immutable. I mean, they could have local state, but you don't consider that part of the function itself, or do you? Maybe this was doing. Cannot borrow more than once, and oh, this is stupid, and this is one of the things I hate about Rust. Why can't I do this? There's not a second mutable call here. Open.push. There are not two versions of mutable. Open.push and open.push. So what you're going to see in a lot of code in Rust, which I think is pathetic, is you're going to see a lot of macros because you can't actually do functions for a lot of the stuff. And I find that's really, it's a weak point. It's definitely a weak point of Rust. And I don't know how they're going to fix it, but it's just terrible sometimes, to be honest. There's just no... Right, so instead of creating closures, which are a proper construction, we're going to end up creating a macro instead. And the macros have stupid syntax. Add open. And you can't create a macro. You have to remember these weird syntax rules. I'm going to say $x, whatever. $x is an expression. And we're going to call it $lock. And it's going to have this code instead. And you probably don't need lock or lock anymore. Lock insert is going to be $lock. $lock. Okay, and that's those are the rules I have. Punch them in. So this is obviously not nearly as clean as a closure would be, because it's not doing the same thing. Yeah, but a feeling if you do that, then the Rust community might really stop helping me. But I think it's a legitimate complaint about the language is that I resort to using macros quite a lot of this stuff. The code I had before here, I think it's totally legitimate. I mean, I have a closure and it's borrowing it, and you want it. Basically, in Rust, it's extremely hard to refactor code that's redundant, because unlike other languages, in Rust, redundant code carries different connotations for mutability in terms of its borrowing checker, and its borrowing checker is extremely conservative, meaning that you can't actually refactor redundant code all the time. You have no choice but to do the redundancy either as a macro or find some other way to do it. And so now I have to have these as macros. And so now this redundancy is this code actually compiles 4 times. If you had to do this a lot of times, this is now actually harder than the compiler in the back end because you've duplicated this code a bunch of times. Alright, so let's try again to understand this here. As we go through this thing, we're going to take the location. For any location we have in the open list, we're going to add all the locations around it. So +1 is to the right, -1 is to the left, plus grid width is 1 down, and there, good thing I did it. Minus grid width is 1 up. This checks all the locations around the grid 1, so very clearly in wherever that game is. So if here's our position, this little red one here, +1 is here, -1 is the blue one, +1 grid width is the green one, -1 grid is the yellow one. These are linear addresses in the matrix. For these types of things, this is why I have linear addressing, because it makes it really easy to do this type of list. So I don't have a list of points, I just have a list of numbers. And I push all of them, but the push says, look, if we've already visited this one, don't do it. Or if it's not a valid address, don't do it. So it's a really simple solution. Otherwise, put it in the visited list and put it on the open list. It's a new place to go. Except we have one more check to do. This fills the whole board. We need to actually limit the color. Which one do we want? And we're going to let cell equal to state.grid.linear_get linear xy. And so we have one additional check here, and that is state.grid.linear_get $lock equals cell. That means we only scan over ones of the same type. So if we start here, we check here, well, there's nothing here, so it's not the same type, so we don't push it. Then down here, it's the same type, so we push it. And here we push it, and then we repeat for all the open nodes until you get everything identified. And there is an optimization here. You can mark visited before you do the linear get, because you can actually avoid checking it, but this here should be logically fine. All right, does this actually compile? Didn't make a mistake. Good. How does this help us? Well, this is the next step. Destroy group at. The first thing we do is we get group at. If group.size is less than 4, then we just return. And we're going to return false. No, we did not destroy group at there. We're going to return 0. This is the size of the group we destroyed. Why not? Let's return how much we destroyed. And we return group.size here as I32. And that's how much. And destroy groups is going to say how much stuff was destroyed. We're going to keep track for no apparent reason. Let's mut gone equals 0. Gone plus equals destroy group at, and then we're going to return gone. Alright, so these are all the groups. We destroyed all the groups. We just have to destroy the group here now. What does it mean to destroy a group? Well, now we have linear addresses. So we have a location in group.iter, state.grid.linear set, and we have this location. And what does it mean to make it not set? We set it to -1. Very simple. We're clearing everything in that group. And you notice we're doing something really weird here, and we don't, yeah. And one thing first, you can just check for this. So if I do state.grid.get xy, x comma y equals -1, or just say less than 0, or I don't know. This is the problem with using integers. Then we just return. This is not. You don't want to scan for the empty spaces on the board. Those are obviously bad. And actually, because 0 is a skull and they can't be destroyed either, when it says less than or equal to 0, and this is hard-coded, and this is like bad magic values. Bad, bad, bad. We'll punish ourselves for that later. I'll punish myself. That's bad magic values, and I should be hit for that. And the problem is working with these optimized things. It's not super simple to set this up. It's not a magic value. It has to be replaced with a function. I can't just, so it's okay. Just pretend I can only replace the colored ones. And only the colored ones can be destroyed. And this will destroy colored ones. And let's check if this works. Applied. Applied. And I'm going to do one more thing here. I'm going to do called destroy groups. Destroy groups. Destroy groups, and I think that's supposed to return a count. Destroy groups. Let destroyed equal. Then we need to do this println destroyed. Destroyed, and I'll dump this data out again. Dump.edump. This gives us our best, quickest option to debug this, assuming it works. Destroy groups. Dupe, this is a, and dupe destroy groups. Group.size, get group, oh. How do you get the size of a group again? What's the size of a vector? Skip that for now. Location, linear set, location. Fine, and size, what's it called? Len? No, is it len? Len? This is a sad point in the world of programming that nobody can ever agree on what the count of a collection should be called. Is it a len, is it a size, or a count? I personally think the C# approach of having count is the most correct, because it's a count of the number of items in the collection. Whereas size is ambiguous, C++ uses size is ambiguous. Do you mean the number of bytes, the amount of allocated space, the total size of all the items, or the count of the items? And that applies to length as well. What does length actually mean? So I think count in this case, count would be the most correct one, but too bad it doesn't have that. Or is it count? Yeah, no, it's len. Count is clearly more correct than is len. And that can become even more brutally clear if you're using strings, because there's lots of different ways to interpret length on a string. So let's play this and see what happens. See if our actual code does what we expect. No, I got a panic error. Wonderful. Panic error. The length is 72, but the index is 76. And this is in somewhere. Linear get group at. Destroy group at. Get best move. Destroy group at. Get group at. Now we don't have the correct things here. Get group at. No, get group at. Somewhere in here is an error. The XY has to be correct, otherwise you would have got the error right here. If XY were somehow invalid, you get the error here, but no, it's inside get group at. So something in here gives us the wrong value. If we add open contains, and contains should be fine. State grid linear is valid. Well, linear is valid should have failed. So if linear valid worked, let's take a look at the matrix here. And, oh god. I have the complete opposite condition. It's greater than 0 and I was pretty brain dead. And less than that. There we go. That's more correct. Let's see if I can see what happens there now. Alright. So I just want to see if it correctly predicted it. There was one there where we had purple and then we played purple. So we have these purples and then we applied the turn and you see that, okay, not there. Now the purple one comes. So we have this in the threes, and so applied, you can see we stuck the threes in over here. So we have this, it's really hard to see, but you can see the threes over in here. We have a collection of threes and destroyed 6. That sounds positive. We destroyed 6, which is that group of 6 there. And so we're expecting these threes and these threes to disappear. And indeed they have. So those 6 have been destroyed. So our destroyed function in this, random one sampled item actually works. Okay, so now this is where the weird part comes from. I've got these functions that can detect if there's a grid that can destroy something good, and but I wanted to check if there's a destruction from the top. So not only is it destroyed, but is it there's something spaced in the bottom. Let me change the algorithm first of all. Let's forget about what we do now. And let's not worry about the fact that I don't have the right destroyed things. Is when I do a get best move, I'm going to change how this works. And there's going to be 2 ways to get a best move. It's going to be based on the cloning and stuff. I want to have a second function here called function get destroy move. State, and it's going to be an optional of I32, I32. And that'll be the first thing this does. And I had a macro that actually tested this, a common macro, and I keep forgetting to use it. And the new Rust has it built in. I think it's question. You can return v. You can return sum. Return sum. So you can do something very simple like return sum. How does that work? Return sum expression self.getDestroy move. Get destroy move state. And what this does is that if this function returns an option or returns the unwrapped option. So now we just have to check, is there something in there? And all this stuff here, I can get rid of it because I don't really need that anymore. Let's keep it for debugging purposes right now. So how do we get the destruction move? Let's do it without rotation first. There are 6 possible turns we can take, 1 for each column. Let's column in 0.state grid width. And I'm just going to try sticking this in every single one of those turns. And I'm going to clone the state each single time. And I'm going to calculate the turn. The turn equals the column. And which rotation? The standard one, the one that makes sense, the standard of 3, 1. We'll take rotation 3. Should make a difference. Turn 3. So this is the turn. So we're going to apply the turn. So I apply the turn to the duplication. And then I'm going to destroy the groups based on that duplication. And if destroyed is greater than 0, that means we destroyed something. I can return this turn, some turn, because it means we found a turn that destroys stuff. And that means that I'm always preferring a move that destroys stuff. And this is just generic. This is not so good because it just throws things at random. It means we're always going to stick the colors on top if I did this correctly. If I did this correctly, it means anytime we're matching colors, we're going to throw them on top. And that's a good test of whether we are so far, like column and state. 4. Turn. Okay, turns down here. No, this is none. Sorry, it's supposed to be none. Only traits may use just as an option of I32. Alright. So if I did this correctly, we should see now that the items get destroyed. So you can see I do prefer destruction now. Except that one time, it missed one. That's weird. Right here. There is a destruction thing there. Oh. I know what the error is. Anybody know what the error is? What happened here? My code detected that it destroys this block. Anybody know why I did that? It has to do with the linear addressing, and it actually a mistake in my linear addressing then. Should not use linear addressing for this bit here. For the containers, fine, but not for the actual addressing. This shit can be decomposed to let x, y equal public function xy from linear and self lock I32. Because I'm wrapping around, and this returns I32 from I32. And this is lock mod self.width. Lock divided by self.width. State.grid.xy from linear. Lock. And this is now going to be an x. It's going to be a $y expression. I'll fix that up later. So this is actually a lot clearer what I do now. Y, x minus 1, y, x, y minus y plus 1, and x, y minus 1. So it doesn't wrap around. So now we check them all individually. I check each of them individually that I say if, well, now I just get rid of this. I'm going to patch let lock equal state.grid.xy Reknakas, let me finish this one thought first, and I'll get back to what approach we're going to take. Grid dot linear xy, x comma y. And this is now is valid $x comma $y. I have to split this up here. The other locations are fine, and this will prevent that move that we just had now. And those are not locks, those are just normal locks. Is valid grid is what? I need it is valid XY. Don't have that one either. This rank keeps going up. Okay, so Reknakas, let me explain what I'm doing right now, first of all. I'm just trying to calculate. I'm doing this simple thing of just take the move that causes some blocks to be destroyed, and this is just part of the simple strategy. The ideal approach, to compile this, then I'll explain the ideal approach again, because I think it's important to see this all and not get distracted. Yeah, and this is another stupid thing about using macros then, is the moment I use a macro, if you have an error in it, it duplicates the error message like 4 times, because I invoke it 4 times. So that's really not very helpful. Okay. Let's make sure I always destroy the bricks. Now, I accidentally pressed play as opposed to play again, so we're going to do a new one. Let's look for any wackiness. Anytime there's duplicate colors, I somehow screwed it up again. So green, why did green go there? Yeah, well, whatever. Let's pretend. So something went wrong. Something's still wrong here. I might have to start debugging this. Why did green not go over there? I have something wrong in the algorithm. Okay, we'll figure that one out. So Reknakas, the approach is going to be okay. Let's describe the ideal approach. There is an ideal approach here. Well, it's not ideal, but it's a really good one. You have these 8 items in the future. You have the one you're going to do, and the next one's in the future. Each one of these has a fixed number of moves you can do. It's actually about 24 different combinations of moves you can do, because it can be rotated. For each one of these, you can actually calculate how much score you get. You calculate the chain reactions and how much score you get out of that. You'll sense a theme from the previous games. You can score the board. Very good. You're going to, for each of those combinations, each of these ones, walk through the full expansion of the tree from this move to this one, this one, this one. What are all the combinations you can put this in for? And this produces 360,000 combinations. We calculated that before. And you pick the one that produces the highest score. That's really the way it does. You can iterate through them all. The issue I'm going to have is that there's absolutely no way, none whatsoever, I can get to 360,000. Perhaps I can do a Monte Carlo, but because we're in debug mode, all of these simple things I'm doing, like these little hash sets and stuff, these little iteration and stuff, are too expensive to do. So if you only got to bronze, there's a good chance we might not get past bronze as well, because I don't have a strategy that doesn't involve an excessive amount of searching and iteration, and Rust on debug mode just can't do that, and this type of game absolutely requires that. I don't think I'm going to get away with a heuristic-based approach, but I'm going to find out. For now, let's let this one play out, and there's definitely an error that I'm not doing something right. Alright, what did I do horribly wrong here? Like, I did something horribly wrong. Add open. Push linear XY. Doesn't contain it. Linear XY, linear XY. State grid XY linear lock. So we split them back out to x. X plus 1, y plus x minus 1, y plus 1. Okay, is valid XY. Let's check the matrix that these functions are valid. X is greater than 0, good. X is less than self in width, good. And y is greater than 0, good. And y is less than self in height. That seems reasonable. Okay, location mod self dot width gives the x. Location divided by self width gets the y. Yeah, Canuckus, I see this is a fairly old one, and the Wood League is very hard in this one compared to the newest ones. The Wood League here, there's a lot of people trapped in it because it is exceptionally hard for a Wood League. I actually have to do a strategy before I get out of it, unless somebody's identified some weakness. But now I have the issue that my algorithm is not identifying the things correctly. So let's go back up to where I said get, destroy, move. What I'm checking here is that for all of the possible moves, do I destroy something? And let's just print these all out. A print line. Turn, comma, destroyed. Let's find out what we're printing. No, 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 no. What does it not like? That. I'm going to replay the same one, and I'm going to find out what goes wrong. We're going to find the exact first place where it fails. Right there. It failed right away. Right, the next green one. The next green one, clearly something's wrong. And it destroys all of them. 0, 0, 0. So you see the three options in all the columns, 0, 1, 2, 3, 4, 5, and 3 is the vertical rotation. And at every single one of those it said, hey, there's nothing. Oh, wait, no, that one. Wait, where is it? Okay. It's not finding it here. So why is that? It's finding it says, why is it not applied? Alright, dup.edump. Let's see what it's applying. Maybe I have an error in the application somehow. Okay, let's apply it. At some point it starts cutting off my arrow output, I think, though, so I have to be concerned about that. Just pause it, don't need to see that. Let's go to the very first state. Alright, you see it's applying it there, then there, then there, then there. It's showing all the very options where it applies it to, and they all have 0, which is correct. Let's go one forward, and now we have the green ones. Now, it's always a frame behind. Alright, so you see, it tries to put the 2's in there, and it says there's nothing to destroy. Then it sticks the 2's here and says there's nothing to destroy. So there's something wrong right there. And this is when I did the linear conversion. So something wrong with the converter I just converted. This no longer finds the fact that something's destroyed. And this should have also found destroyed. So that destroy code is now no longer working. The application is working, so we have the right thing, but the destroy code no longer works. And the destroy code says destroy groups. Reknakas, yes, I'm calculating the groups by flood fill. So go with right now. So for the destroy groups, I go through the whole board and I say for every single cell on the board, let's destroy the group at that point. Good. If there's nothing at that point, skip it. Great. If get group at that point, if the length is less than 4, return. That's fine. And otherwise, we clear the group. But the fact is get group at is now failing. I give it an x and a y. Linear x, y, get, that's a cell. Insert, insert. And location linear x, y is fine. Like this was working before, except for the fact that it wrapped around. And so now that it's not wrapping around, but it's not doing anything whatsoever. XY. State grid XY linear lock. The only thing I think is that's wrong. I should really make test cases for this. Lock mod self dot width. Lock divided by self dot width. That's totally fine because it's the exact opposite of this. What's the problem there now? How can I... Man, I don't want to write a test case today. This is silly. One of these functions is not doing the right thing. Which one, though? Which one's not doing it? XY linear. XY linear takes a lock and returns the XY, and then they call add open on X plus 1, Y, X minus 1, Y, X, Y minus 1. Do I have to write test cases? I hate setting up test cases. I don't see what I could be doing wrong. What the hell is wrong here? Yeah, let's just flood the thing. X comma Y. Go away and go right to the top. Let's go down, frame, frame, next frame. It looks like it's decoding correctly. So I think the decoding's fine. Encoding, decoding, otherwise you'd lose these values. But it's only ever outputting one, so it's only ever checking one. It's never, none of them are ever being marked as valid. So it's probably not the visited. And let's check this out. Well, is valid XY. That's the bit that changed. Is valid XY. What if I put this back to... No, that was wrong. Is linear valid. Is valid XY. Let's check very carefully what is valid XY does. It should have been XY is valid. X is greater than 0 and X is less than the width. And Y is greater than 0 and Y is less than the width, height. That seems like it's fine. Let's change the name first to be consistent with the other one. Don't know why I'd call these names. We don't have consistency, but if I see one, I'll do it. So now I can do linear is valid with lock instead and see if that actually gets us at least back to where we were before. Does this at least detect where it is? No, so something's still fundamentally wrong there. I don't know, I've lost track of what's actually wrong there, and I don't... Alright, let's do more debugging. V equals visited. Let I equals whatever. C equal if not V and I and C. E println star this, we're just going to do this, and x comma y equals lock. Test cases, unit tests are really helpful here, but I just don't feel like setting them up, sorry. I'll set them up offline if it doesn't work so that next time I come back I at least have this working. What happens now? Oops, I pressed the wrong button. That should be fine. True. That seems fair. And what? So you notice the error 0, 10, and it feeds in 0, 10 into the algorithm 4 times. And oh shit, this is where it is. It's right here. This is why I don't like using macros as opposed to closures and the that XY's already been defined and it's fixed, and because I wouldn't have this problem with a closure because I'd have a masking of the XY. That's annoying to say the least. I'm pretty sure all this other stuff is fine, so let's just get over this. Get group out, that's fine. Okay, now that should work. So that finds the groups, and we're just going to destroy the ones. So if you can destroy, and oh, now I did something wrong again. Of course, it's out of bounds. What did I do wrong now? Alright, yeah, because I have to stick the stuff in here because I rely on the lazy evaluation. Stick that here and then just do this way. Stick that in here and just do this. You can't calculate them outside of it because of the fact I'm relying on the lazy evaluation. So you can't call linear get if XY is not valid. And there's our flood fill. Alright, so it looks like I'm identifying blocks together now, and this approach doesn't really work. We're going to die from this anyways. The idea here was, though, I'm actually going to defer, and only if I have a block that's underneath something that's destroyed am I going to do that. And so that's going to be something slightly different. Instead of going destroyed, it's not enough to be destroyed. There has to be an emptiness. And I'll quite literally like that as simply down here, if destroyed, and let's say it has drop, because that's what's going to happen, and state, dup, and dup. If it has a drop as well, then it's going to return that. Only in the case where it has a drop. That's waiting for the cases that set up a potential combination move. Function has drop. And this takes a state and state. It returns a Boolean. And I'll just check each row for I and 0 dot dot. State grid width. And this should just basically toggle it on and off. And when I start from the bottom or start from the top. So I have to walk through the height of it, and I have to say if there's a hole. So if there's a hole, I start from the bottom. If there's one missing, good. And then if I find another one, great. Okay, so how do I do that? Let's start with has equals state.grid.get get x, y, I, comma, state grid height minus 1 is greater than or equal to 0 is fine. If not has, then we can continue. Because it doesn't have the bottom one, then there's no hole in it. Good, so now we've established that it has it. I think now we can simply walk from the top. No, what do I have to do now? Now I want to walk upwards. Alright, I just tried. So for y, I know I call this x. I don't know why I keep calling it I. Force of horrible habit. For y in 0.state grid height, let next equal state.grid.get xy x comma state grid height minus y. This has to be 1. We're already starting the second one. Minus y is greater than or equal to 0. And I should probably just count the number of flips and flops, the number of targeted edges. Alright, so we're going to say it's like the edge count. Let's put edge equals 0. So if it is a next one, so if we have a next one, great. Else we don't have one. And this now means that if we did have one, if we didn't have one before, then the edge count goes up by 1. Because it's going up. If we didn't have one before, and now has equals true in either case. Else has equals false. So this counts any upward tick in the motion. And we skip the first one because the first one says, look, if it's 0, we skip that. And now if edge is greater than 1, no, greater than 0, as long as there's any edges, then we return true. Otherwise, we return false. So this is just checking for emptiness in that thing. And what does it want me to do? What is it getting mad with me now? Has, this is a mutt has then. I don't know if this algorithm works. We're going to find out. Like I said, again, I'm just trying to see if there's holes. After the destruction of the items, are there holes? And let's find out if it does something. And turn the speed down to 2 times, and it actually wins now. Impressive. So let's find a case where it finds a hole. That wasn't a hole, but it was still happy with it. I don't know if I found a hole or I just got lucky. It's not actually proven that my algorithm works yet because I've not detected the situation I'm trying to detect yet. Ah, there was one. There was one right there. Right here, the purple one. It correctly identified to put it here because it leaves a hole there. See? And then it drops. So at least we have one location, just at least one location that it actually provably works. And that somehow beat the boss. And that was the one we lost on before, so that one slight difference maybe perhaps worked. Let's play again against me, again another one. See if I just got lucky or not. No, that slight change it is detecting a few combinations. Yeah, let's just submit that. Let's do. I could care less. If it beats the boss twice in a row, that's, you know, from extrapolation, it must always beat the boss. Doesn't beat the other people very well, though. And I am identifying holes. I can clearly see that. I am definitely identifying holes. Whether that's good enough, oh, I dropped down to 1,000, so who knows? Maybe there's some good guys on there where I have to get past first. And this game's a really hard one to watch because in fast mode it goes by too fast, but in slow mode you don't see, yeah, it's hard to see what's happening. But I do definitely set up combinations. It's kind of luck based though that I get them. And that's because the other code where I have doesn't really care where it puts stuff. But I can beat the boss now, which is a good sign. Just all those other people's strategies, I got to figure out what they do. So now, it's a good sign though, because that was the current thing I wanted to identify, is I wanted to detect holes. There's a lot of code there to get those holes detected, and you can clearly see a combo was set up. By accident again, but I mean, at least the accidents can happen now. They could not happen before. So now they can actually happen. And I'm going to continue this tomorrow night, but I'm not sure how I'm going to continue this. I was really hoping, it looks like we have to do an actual strategy and where we place it. When I can't do the combination, where do I place it then? And this guy just does, of course I beat that guy because it's not very hard. But this actually does overall worse. It doesn't matter that I beat the boss. Overall, this is actually doing worse than that previous one. But I might have just gotten unlucky with submit. And there's probably nobody else playing this game right now. So we're the only one playing right now. So that's fine. And 906. I have a feeling if we get up in the ranks. So tomorrow I have to think about how can I actually intelligently position those other ones to set up the combinations. And that's where I may just reduce back to what the I don't know how the computer's doing it, how they're setting up those combinations, but somehow I think it can be done. I don't know, but I think I'm going to leave this. We're not going to get any higher than this. So I think that's it for the day. I was trying to get further. Again, the Wood League in this one looks surprisingly harder than the Wood League in the other ones. And again, this is really unfortunate because it means we probably have more instructions in the Bronze League that aren't going to be accounted for. And so this approach I have now is actually worse than the one I had before, which is kind of weird. But I'll figure that one out tomorrow. So I thank you for watching. It's a new game, and tomorrow I'll just continue on that. Please remember to follow and subscribe and all that fun stuff, and talk about my show, tweet about my show. It really helps out to get the number of viewers up. Thank you very much, and until tomorrow.